two very important problem of numerical integration, in particularly from trapezoidal rule. And the problem are, the first problem is how big should the spacing h be so that the error in computing integration 1.8 to 3.4 e to the power h dx using trapezoidal rule is less than or equal to 0.5 into 10 to the power minus 5. This is the maximum error it is given. Okay, and second problem is same, but the integration is different from the first problem. Here integration 0 to 1 e to the power x dx, and here also it is said that corrected to 5 decimal places. Okay, and corrected to 5 decimal places, that is the maximum absolute error. We know that if a number is correct to 5 decimal places, then the maximum absolute error EA, this is less equal to half into 10 to the power minus 5. That is less equal to 0.5 into 10 to the power minus 5. Okay, so this term and this term are same for this problem. Now if we consider an integration a to b fx dx, okay, then error in trapezoidal rule, we name this error is ET. This is given by minus h q by 12 into f double dash xi. Okay, and xi is lies between a less equal to xi less equal to b. This is the trapezoidal rule error. And here I solve the first problem, and the second problem is your homework. Okay, now for the first problem and the second problem also, here fx, this is equal to e to the power x. So we get f double dash x, this is also e to the power x, right? Now for the first problem, b minus a, this is given by 3.4 minus 1.8, this is 1.6. So the length of the interval is 1.6. We have to find out the spacing h so that the absolute error is maximum is equal to this. Okay, now the maximum absolute error is given by ET, this is equal to minus HQ by 12 into max of, this is f double dash xi, so this is equal to e to the power xi. Okay, e to the power xi, and the maximum value of e to the power xi in this interval, that is in the interval 1.8, 3.4 is given at 3.4 because e to the power x is increasing function. So we get this is minus HQ by 12 into e to the power 3.4. Now our condition to find the value of h is given by HQ by 12 into e to the power 3.4, because we take the error in positive sign, and this is less equal to 0.5 into 10 to the power minus 5. So we get HQ less equal to 12 into 0.5 into 10 to the power minus 5 by e to the power 3.4. Okay, and this gives h less equal to, this is 6 into 10 to the power minus 5 by e to the power 3.4 whole to the power 1/3. Okay, and now calculating this term by calculator, we write the result directly, which is given by less equal to 0.012604. Okay, so if the length of spacing or space length or step length for this formula, if we taken as less than this term, then our absolute error is less or equal to 0.5 into 10 to the power minus 5. And for this problem, we say that by calculating this type of calculation, we say that our result is corrected to 5 decimal places. Right? Now, here we take h, this is equal to 0.01, because this is less equal to 0.012604. Okay. Now, why we take this type of h? Because we know that the number of subinterval for trapezoidal rule or any other rule must be a positive integer. Okay. Here it is already calculated that the total length of the interval b minus a, this is equal to 1.6. If we take this h, then 1.6 by 0.012604, it is approximately equal to 133.33. I think this is. So this is not a positive integer. So we get h is like this, 0.01. This satisfies the value of h. And in this case, the number of interval is given by 1.6 by 0.01, that is 160 interval. Okay, and by taking 160 interval or by taking h, this is equal to 0.01, which is the space length, we get the error for the trapezoidal rule is less or equal to 0.5 into 10 to the power minus 5. Right? Very easy problem, but important problem of your exam. And you must write in comment box the answer of the second problem, that is the value of h for this problem we calculated by the same type of calculation. Thank you for watching.